Okay, here we go. Trent, I'm actually teaching right now. We are live. Shh, shh, shh. So, now that my class is quiet, I'm going to record. So, I like to start logarithms with an example. And my example would be this. If we have 10 to the x equals 100, I know x has to be 2 because 10 to the 2 power is 100. Or, if I have 10 to the x equals 1,000, I know x is 3 because 10 to the third power, 10 times 10 times 10 is 1,000. But then the question is, what if you got x is 10, x to the 10 equals 500? You would think the answer is 2.5. Okay, so I can check it. What is 10 to the 2.5 power? But it's not even close. So how do we solve this? Well, we have a button called logarithms. So what I'm going to do is if I take the log of 500, it's on my calculus right there. So if I take the log of 500, I get about 2.7, really close to 2.7. So x is approximately equal to 2.7. I can test that by going 10 to the power of that answer, and what does it get? 500. Now logarithms then solve exponents. So what I did on my calculator is this log. This is log base 10, okay? Log base 10 we call the common log. It's called common log because we count in base 10. So we looked at the logarithm formulas, okay? There is a formula. If we have any base to an exponent, we can change that to a logarithm, okay? And I just abbreviated that. I went b to the e, or base to the exponent equals the answer. You can change that as an inverse. Its inverse is log base b of the answer equals the exponent. So we took example A. So okay, let's change this from exponential form into log form. So we rewrote this log base 2 of 8 equals 3. Okay, that's changing it from exponential form to log form. B, okay, same thing. I'm going to go log base 10 of 100 equals x. Or log of 10. If there's no base, it's base 10 common log. So if it's invisible, it's always 10, okay? Parker! What? I'm trying to record, for God's sake. Seriously, give me that. Sit down. Now you're on film forever, okay? You will be infamously known. Okay? Knock it off. Now, E. If I have the natural log of E, I go log base E, but log base E is a weird log, but in our calculator, it's considered natural log. So you see, log base E, it's going to be ln of E. Okay, so whenever you see ln, it's log base E. Okay, now, moving on. Let's go the other way. Let's change from log form into exponential form. So here's my base to my exponent equals 16. So 4 to the x equals 16. On this one, invisible base is 10. So I'm going to go 10 to the x equals 1,000. C, if it's ln, it's log base E. So I wrote the E, and it's going to be e to the 4 equals x. Okay, so we've changed it from log form to exponential form to log form. Okay. Now, how do we use logs? Well, we can solve logs. So I put an x here and rewrote it in exponential form. 3 to the x equals 81. 3 times 3 times 3 times 3 is 81, so x is 4. 5 to the x, I changed it to exponential form. 5 to the x equals 1. Has to be 0 because anything to 0 power is 1. This one I'm just going to use the calculator because it's common log, base 10. I can just go log of 431. I got about 2.63. Johnny, sit down.
Okay.
On the back, we've got some log rules, okay? If we log of some base to the same base, it always equals 1. If we have log of some base to its base to some exponent, it just equals the exponent. We know that log of 1 is always equal to 0. Logs can't be 0. It's undefined. I'll show you a log of 0. It can never be 0. and it can't be negative either, okay? So we use these rules and we simplify the following equations, okay? 10 to the log base 10 of 3x is just 3x. Log base 3 of 3 to the 2x is just 2x. And you cannot take the log of a negative number. So if I go ln of negative 2, I get an error. It cannot be negative, okay? So finally, we talked about their graphs. So I graphed y equals 2 to the x. I plugged in 0, 1, 2, 3, 2 to the 1, 2 to the 2, 2 to the 3, and I graphed those points. I even did 2 to the negative 1, 2 to the 1/4, and I graphed my graph. I have an asymptote at 0. My domain is all real numbers. My range is y is greater than 0. But then I did the inverse. So I switched the points for its inverse, and I graphed its inverse. Switch these points. The domain of this is going to be greater than 0. The range of this is all real numbers because the domain of one is equal to the range of the other. So since they're inverses, it's the log. So log base 2 of x is the inverse of this. Okay, that's all I have. Kind of disappointed that I wasn't able to record. I'm kind of disappointed that you guys had to